This podcast is brought to you by the Maryland State Library Agency. The MSLA podcast features presenters from statewide youth programs, as well as learning opportunities for library staff and resources for patrons of the Maryland State Library for the Blind and Print Disabled.
The following is a presentation of the Technology User Group at the Maryland State Library for the Blind and Print Disabled. For more information about the Technology User Group, including upcoming sessions or archived recordings from previous sessions, please visit our website, lbpd.maryland.gov. That's L, B as in Bravo, P as in Paul, D as in Delta, .maryland.gov.
Would you like to get the Technology User Group presentation every month with little effort? Just subscribe to the Maryland State Library Agency podcast using your favorite podcast catcher. Then each month you will automatically receive informative and inspiring presentation. Remember, you can also listen on your smartphone or speaker. Say something like, Alexa, play Maryland State Library Agency podcast.
Without further ado, I'd like to introduce you to Dr. Amy Bauer.
Thank you very much, Jerry. Can everyone hear me all right?
They're muted, so we'll say yes.
Oh, okay. You aren't, but you can. Okay, I'm sorry. Yes, of course. Well, I want to start out by saying thank you for inviting me to talk to you today, and thank you for coming out to listen to this presentation. Before I start, I just want to suggest that later on I'm going to be playing some audio clips, and you will have a slightly better listening experience if you listen through headphones to your through your computer. It's not essential, but I thought I'd give you that little heads up early on. So in case you want to scrounge around on your desk to find some headphones to plug in either now or later, you'll have the opportunity. Okay, my name is Amy Bauer. I'm a research scientist at the Woods Hole Oceanographic Institution in Massachusetts, which is on Cape Cod. It's about an hour and a half drive south of Boston. I am a physical oceanographer. Oceanography is actually a very broad field. Most people, when they think of oceanography, think of whales and sharks, maybe fish, maybe waves, maybe swimming in the ocean if they've had the opportunity to go to the beach. But there are actually many different aspects of ocean study and ocean science. Biology is one of them for sure, and that includes what we call the charismatic megafauna, which are big whales, but also geology from sediments on the coastline, studying how those move, to underwater volcanoes, tectonic plate geology. Then there's also the chemistry of the seawater, which isn't just one big uniform soup. It's actually is very structured. And then there's the field that I'm in, which is physical oceanography. Physical oceanography is the study of physics in the ocean or forces in the ocean that cause it to move. And so in more layman's terms, that would be sort of the study of ocean currents. And that's what I do. I investigate and try to describe ocean currents. Ocean currents are like there are many of them, and they are like huge rivers in the ocean. Slowly, they're not fast, like you might see a strongly running brook or river. They're slow, but they're huge, much bigger than the Mississippi River. For example, some of them, they carry a lot of water and also move around other properties of in the water. And I'll get a little more into that in a minute. So you might wonder, how does somebody get into this field? Well, I grew up on the coast in Massachusetts, in a small town, seaside town called Rockport in Massachusetts. And as a kid, I was normally sighted as growing up, and I spent a lot of time on the beach. Not suntanning like a lot of teenagers did at the time, but, turning over rocks and looking out at the waves and, developing a curiosity about how the whole ocean thing worked. What was out there? What was out there beyond the horizon? And that was also augmented by a developing love of the environment in general, mostly driven by my mother, who also was a big outdoor enthusiast and conservationist and activist. And we spent a lot of time in the outdoors, going to wildlife sanctuaries and exploring and cabins in the woods of Maine. And so I just really developed a great love of the outdoors in general and sort of the natural environment. In high school, I kind of found myself a bit more attracted, though, to physics and math compared to biology. And so I got quite a bit of, extra training in that, and then went off to Tufts University as a physics major and started their traditional physics curriculum. But I realized I didn't want to do what most physics people do. I wanted to do geophysics, which is geo, earth, and physics together, physics of the earth system. When I was an undergraduate, I had the chance to do a program, and also happens to be here in Woods Hole, called Sea Semester. It's operated by Sea Education Association, where you spend 6 weeks in the classroom learning everything interdisciplinary about the oceans, including maritime history, literature, oceanography, policy. And then you spend 6 weeks at sea on a tall ship doing scientific research and learning how to sail this tall ship. And it was a transformative experience for me, and also where I learned there was a field called physical oceanography. And this is where I learned I could combine my sort of training and interest in physics and math, and I could combine that with my love of the oceans and my curiosity about the oceans. So I found out also that in order to get into that more, I would have to go to graduate school. So I went off to the University of Rhode Island, started a PhD program there. I was a couple years into that when I noticed some vision changes and was eventually diagnosed with retinitis pigmentosa. This was a shock. There was no history in my family of this. It gave me severe pause at that moment in my life. I was about 22, 23. I was super excited about what I was doing and the outlook for this career in ocean science. But I didn't know a single blind person at all, personally. And I certainly, therefore, didn't know any scientists who were blind or low vision. So it occurred to me that maybe this wasn't possible. There was nobody doing it that I knew. That's important. There were people doing it, but there were many, and I didn't know them. I've since learned there are many, and they make up a very strong group. But it was a scary time, and I was trying to understand, what was the outlook too for my vision. And the ophthalmologist, well, probably going to slowly decline over time. You may or may not become completely blind eventually. And my ophthalmologist's advice was to not do research, not pursue this degree in ocean science. And that, of course, was devastating to hear. I was devastated for a while by that news, but I could not think of what else I wanted to do. I couldn't think of anything else at all that I'd be as interested in doing. And then I got angry. I got angry at this ophthalmologist because he did not ask me any questions about my science or my research or my, the details and like what vision would be required. He didn't say anything about adaptive equipment or tools or software, nothing, and so I several years later, wrote him a letter, and I told him how angry I was with him at that time. And I suggested to him that he not give out advice to young adults like that, considering I didn't say he was uninformed, but he was uninformed about adaptive technologies and the capabilities and persistence and determination of all people, including blind and low vision people who have a passion for something. And he should not underestimate that and give professional advice. So, but then around the same time, I also met a low vision specialist who was the opposite. He was a can-do guy. And Jerry Friedman, he's retired now. He's in the Boston area at the time. He was completely the opposite attitude. He asked what I did. He kept thinking I was a scuba diver, which I wasn't. But even if I was, he was all ready to get me special lenses for my mask, a dive mask. But he introduced me to the CCTV for starters, okay, and the video magnifier. And that was just the beginning. And that's when I started to get the idea, okay, maybe I can do this. I can do it at the moment with these tools like a video magnifier. So let's just take it one day at a time and see how it goes. But nonetheless, over many years, as my vision declined, I had doubts. I don't want to come across as someone who just marched confidently forward in my career thinking, okay, this is easy. It was not easy. And I've had doubts my whole life, including up to this day, even though I'm actually near retirement age now. Every now and then I say, if there's a new challenge or a next step in my career, I was always a little doubtful about it. But, I just decided to take a day at a time. And like many people who become blind rather than being born blind, I tried to hide it for a long time, as long as I could, especially when I was applying for my first job, which was as a postdoctoral scientist at Woods Hole Oceanographic Institution. I wasn't yet using a white cane. I could kind of fake it a bit. My original symptoms were central vision, so I couldn't recognize people, but my mobility was pretty normal for quite a while. So anyway, I managed to get a postdoctoral position at Woods Hole, and then eventually joined a couple of years later the scientific staff, and then earned tenure eventually, and et cetera. So I want to talk for a couple of minutes about accommodations in the workplace. So as time went by in my career my early career, I realized more and more I did need more accommodations, like a computer which is where I do most of my work, was getting harder to see. I tried to pump up the font size, whatever was available. Then this would have been in the early 1990s. But then I said, I think I need to look a little deeper. And so the first safe person I felt I could talk to openly about this was an ombudsperson at my employment. And in case people don't know what that is, an ombudsperson is usually a safe person to whom employees can talk about sensitive issues without any, unless you choose it, without any escalation of the issue to the HR department, for example. I didn't want that at first. I just wanted to speak in confidence with somebody about what I needed. Well, lucky for me, the ombudsperson at Woods Hole was fantastic and incredibly supportive. And she said right from the beginning, whatever you need for accommodations, you ask, and we will likely be able to accommodate. And that has proven to be the case through various leadership teams at my employment. We've had many directors since then, and HR directors and EEO officers and ombuds people. And they have all been, without a doubt, extremely supportive. And I want to say, I recognize that is not the experience of all employees in the US or elsewhere who are blind and looking for accommodations. I've heard some real unfortunate stories, about people being refused reasonable accommodations. So I feel incredibly fortunate that my employer has been very forthcoming. And so the accommodations that I asked for and received, besides the video magnifier, was scanners, originally back where we used to have to scan something and then import it into the computer to have it read. And then magnification software at first for my computer. I used ZoomText for the original ZoomText for a long time. Then as my vision got worse, I needed to get into speech. So I requested them to pay for the software for screen reader. And then also a little bit of travel assistance to go on research cruises and conferences. And so all these adaptations allowed me to continue with my career. I want to say it wasn't easy. It would have been impossible, I think, without these accommodations and adaptations. And I'll talk more about that in a minute. So what do I do for research anyway, you might be asking? As I described, physical oceanography is the study of ocean currents. And so I study ocean currents. Why should we care about ocean currents? You may be asking yourself. Well, ocean currents are actually a critical part of Earth's climate system. Ocean currents carry a lot of heat all around the globe, and they also carry a lot of gases like carbon dioxide and oxygen. The oceans have absorbed a lot of the carbon dioxide that we have been putting into the atmosphere by burning fossil fuels. Something like a quarter of it has been absorbed by the oceans. And then the ocean currents carry that carbon dioxide deep, deep in the ocean where it can remain for thousands of years. So in a way, the oceans have saved us so far by absorbing a lot of the extra carbon dioxide. Otherwise, we'd be in bigger trouble than we are in terms of a warming climate. But ocean currents also affect how pollution spreads. And so if there's a spill of some kind, we want to be able to predict and hopefully expedite the cleanup of pollutants. Another obvious, search and rescue. When people or goods fall overboard, we want to be able to know where they're going to drift so we can hopefully rescue them. Transportation, ocean shipping, and of course, military and navies of all countries, very interested in ocean currents. So I specialize in deep ocean currents. These are far below the surface. And I think it's quite an irony that nobody, sighted or not, can see the ocean currents that I study. It's pitch black down there, but these ocean currents are a big part of the climate system. But they're difficult to measure and not very well known. And so I love the exploration aspect and the discovery aspect of this work. And I primarily use drifting buoys that don't drift at the surface like you might think of a buoy or a message in a bottle or something like that. These are specially designed instruments that drift down deep, and they're tracked underwater using sound. So my day-to-day work, like what are the tasks I have to accomplish, as part of this research? I work at what's called a soft money institution, which means I have to raise money for my own salary by writing proposals to get grants, mostly from the federal government and some from foundations. And I have to get all the money to do my research, including pay technicians, purchase equipment, pay people, including myself, to go to sea and deploy our instruments. I have to raise the money by writing these grant proposals. So I do a lot of reading and writing. We collect measurements of ocean currents using the buoys that I described before. So we have to go out to sea on research vessels and deploy our instruments sometimes, and then recover them afterwards. Okay, then we get the data from those instruments. So I have to analyze the data. That's something I do on the computer with computer software. And of course, part of getting the measurements is going on research vessels. That's part of my life too. Every few years, I go on research vessels. That part of my work has changed over the years because of my vision. I used to, I still do, lead the cruise. I'll be the cruise science leader most times, but I'm not out on the deck handling the instruments anymore because that would not be a safe environment. It's a bit like industrial work in a way, hard hats, steel-toed boots, because you've got heavy equipment swinging around and going over the side and being recovered. And when you can't see, it's just an unsafe place to be. But I can be in the lab at my computer, helping with decision-making and planning of all the activities at sea. And then after I get my data and analyze it and figure out what's going on with the ocean currents, I have to write reports and articles for peer review, get those published. That's how the science moves forward. I also write some computer software as well. I go to meetings and conferences, every few months or a few times a year, I guess, where I present my work. I listen to the work of others, the research results from others. So all of this, I want to say, is not solo work. I could not do this by myself even if I was fully sighted. Oceanography and most scientific disciplines now are highly collaborative. There might be a number of principal investigators like myself working together, each one bringing their expertise. But there are also a huge cadre of support personnel, from engineers who build the instrumentation, technicians who help convert the measurements we make into sensible numbers, even graduate students, postdocs who contribute to the research as well, and even down to the ship's cook and the secretary down the hall are all essential players in the scientific endeavor. And I try to make sure to mention that because there's many pathways and careers in science. They don't all require a PhD in oceanography or any other science in order to have a really fulfilling and interesting career in science. If you want to learn more about the research process, I would recommend a book. It's on the Bard, called 7/10, like the fraction, except it's written out in words, SEVEN, 7/10, TENTHS. And it's written by David Fisichella. I'll spell that out. F as in Frank, I, S as in Sam, I, CHELLA. David Fisichella. And as I said, it's on the Bard. David is my husband. And after we met, he had the opportunity to go on a couple of oceanographic cruises for the first time. And he wrote a book that is partly about his experience learning about oceanography from the outside, sort of an outsider's view of the field and what it's like. It's a little bit about our life and getting to know each other and eventually getting married. And also it's about some of our amazing adventures at sea. Some of them are astonishing. Some of them are scary. And so I really recommend that book. He's a great storyteller. So I just want to mention one more thing about accommodations, because this is recent in my life. I learned about a new accommodation that I could possibly request and receive called fast salary support for an access assistant. I got this idea from Dr. Mona Minkara, who is a professor of bioengineering at Northeastern University, who's blind. And as part of her startup at Northeastern, she requested salary support for access assistance. And I love the term. I think it's really great. I had access assistance in my work as well, but in a very ad hoc basis. So I asked my employer, would you support as an accommodation part-time support for a person whose job it is to help me get access to materials related to my research? And they said yes. I was grateful and surprised that it went as smoothly as it did, but they said yes. So my new access assistant started just in April, and I wish I'd requested this 10 years ago. It is a game changer. I've been limping along, trying to keep up, especially with graphics, which are still one of the most challenging aspects of being in science, is having access to graphical displays of data, visual displays. And now I have an access assistant whose job it is to just use many different techniques. There's no one technique, whether it's a verbal description, write alt text, use swell paper to make a raised line drawing version of the graphic, make a 3D model. That one, we're only at the beginning of that one. We have a long way to go on that, but that's promising. And then what she also can do is do research on emerging technologies. Like many of you may be aware of the ChatGPT and similar options for having images, photos, graphics, plots described by using AI, artificial intelligence. And that is very promising. But my job is to be a scientist. I don't necessarily have the time to research that and how those new technologies might help me with my research, right? So to have somebody whose job it is to research that for me and come to my office and tell me, Amy, this is this new thing, that may really work. Let's try it out. Has been a game changer for me. Really important. And I want to encourage others in a similar situation to request that as part of their accommodation. So another technique that we are exploring more and more that's relatively new is data sonification. And this is what I'm going to spend the rest of the time talking about. And I'm going to play some demos for you in a minute. So data sonification, what is data sonification? Data sonification is the translation of numbers, data, numbers, into sounds. And then the development of a display or an audio track of that data that is clear enough and has enough context information for a blind person to then explore that data, understand the data, what's the story the data is telling, whether they're sighted or not sighted. That's the basic concept. And I've been exploring this technique for two purposes. One is for my own research. I just going crazy here trying to make a comfortable bed in this crate. One is for my own research, and that is my ultimate goal, is to be able to become good at this data sonification for the purpose of my own research. But it's also very valuable for outreach and public education. And so I've been exploring that as well. I love public education. I love helping to educate the public on the importance of the oceans, which they tend not to know as much about as they do sort of the terrestrial environment, or even space. NASA is very good at public education. So I'm also interested in that, and using data sonification to help sighted and non-sighted visitors to museums be able to understand and perceive and learn something from data. And this can also be a very useful tool for anyone who maybe has low math literacy or dyslexia or some other learning disability that makes it very difficult for them to interpret a visual graph or plot of data. So to get into this field a little more, I put together a team of researchers, and we applied for money to research how to put ocean data specifically into sound. And the name of the project is called Accessible Oceans. I'm so fortunate to have this wonderful team of people working with me on this. It includes a professor of learning sciences from Georgia Tech University in Atlanta, a sound designer who specializes in data sonification from the University of Oregon, a ocean science consultant and specialist in science communication, who has her own consulting company, Your Ocean Consulting, LLC. And then there's me, who's an ocean scientist with low vision. And I really believe that, there's that phrase, nothing for us without us. I really firmly believe that blind and low vision people need to be involved in the development of new tools that are to help them out. So after 2 years of working on this project, we have come up with several what we call prototype auditory displays. This was a pilot program, so we just were making prototypes, like just feeling our way along, like how would we do this? We looked at many other types of data sonification that have already been done. We tested our ideas with sighted people, non-sighted people, adults, children, people with a science background, without a science background. And we came up with about 4 or 5 final prototypes, which we hope now to use to show we know what we're doing now, and to get another grant, a research grant, to develop a museum exhibit that would feature data sonification of ocean data specifically. So I think I'm going to play for you now. Let me make sure. Oh, I want to emphasize one thing. When we get to the data sonification, I want to remind you that what you're hearing are not the sounds of the ocean. They're not the sounds the ocean is making. They are sounds that have been created using computer software from the data, from the numbers, measurements of different phenomena in the ocean. And the rest will be kind of self-explanatory. I think I'm still sharing my screen, so and with sound, so hopefully you'll be able to hear it. So, Jerry, I might ask you when it starts just to confirm that it's coming through okay once I start.
I'm ready.
Okay, perfect. So what you're going to hear, it's about 6 or 7 minutes long, and we call it an auditory display because it includes narration and information about the data sonification, which then you will hear after the narration, and it's interspersed together. So let me give it a try.
It's working.
Excellent. Okay, I'm going to say nothing.
Do you recognize that sound? That's the sound of carbon dioxide leaving a bottle of soda. Carbon dioxide also goes in and out of the ocean. Let's explore with our ears. Carbon dioxide is an important gas on Earth. Plants need carbon dioxide to grow. Its presence in our atmosphere also helps make our planet habitable, trapping heat from the sun and keeping our planet much warmer than outer space. The increase in carbon dioxide due to fossil fuel burning, however, has made far too much of a good thing. The increase in carbon dioxide in the atmosphere is trapping too much heat and is causing global warming. Much of the excess carbon dioxide in the atmosphere is being absorbed by the ocean. Scientists are trying to understand what controls the natural exchange of carbon dioxide between the ocean and the atmosphere, so we can better understand these human-caused changes. When carbon dioxide is released from the ocean into the atmosphere, that is called outgassing. When carbon dioxide goes from the atmosphere into the ocean, that is called absorption. One of the most important factors that controls the exchange of carbon dioxide between the ocean and atmosphere is the temperature of the seawater. Cold water can absorb much more carbon dioxide than warm water. When water warms up during the summer, carbon dioxide is released from the ocean into the atmosphere. As water cools down during the winter, it is able to absorb more carbon dioxide. Let's listen to some data. As you listen, outgassing will sound like this. The more gas that is released into the air, the more the sound will become louder and brighter like this. Now, let's listen to outgassing over the course of 1 year at the OOI Coastal Pioneer Array off the coast of New England in the North Atlantic. Listen to when outgassing occurs. More carbon dioxide is released from the ocean during the summer months when the water is warmer.
Winter. Spring. Summer. Fall.
What about when the ocean absorbs carbon dioxide? As you listen, absorption of carbon dioxide will sound like this. The more carbon dioxide that is absorbed into the ocean, the louder the sound will become like this. In this soundtrack, we will hear absorption over the course of 1 year. Listen to how absorption changes throughout the year.
Winter. Spring. Summer. Fall.
Did you notice how much more carbon dioxide is absorbed from the ocean during the winter months when the water is colder? Now that you've heard outgassing and absorption processes separately, let's listen to them together. During this soundtrack, the sounds of outgassing will occur on the left channel, and the sounds of absorption will occur on the right channel.
Winter. Spring. Summer. Fall.
When we hear it all together, the ocean almost sounds like it is breathing. Breath in during the cold winter, breath out during the hot summer. Absorbing carbon dioxide when it's cold and then releasing or outgassing when it is warm. What about other parts of the ocean? Are the patterns of outgassing and absorption similar or different? Let's head down to the South Atlantic and listen to data from the middle of the Argentine Basin, far off the coast of Argentina, where the ocean surface waters are much colder. Again, the sound of outgassing will occur on the left side, and the sound of absorption will occur on the right side.
Summer. Fall. Winter. Spring.
Did you notice that there was actually no outgassing in this soundtrack? Carbon dioxide was absorbed by the ocean during the entire year. This is because the ocean water temperature is much colder at this location, and so the ocean absorbs carbon dioxide from the atmosphere year-round.
Okay, so that was one example. And I have another one. And then let me check the time. 10:41. I want to leave time for questions. Maybe what I should do at this point is pause and kind of close out my remarks here, and so that there's plenty of time for questions and conversation. And if at some point in the next 20 minutes, anyone would like to hear, or the group would like to hear another one, I can play another one. They're all like 6 or 7 minutes long. So if you think that sounds like a good plan, Jerry, we could open it up to questions and discussion.
Anyone who wants to ask a question can unmute themselves and ask a question. Of course, Alt A unmutes on Zoom, or star 6 if you're on the cell phone. Alt A or star 6. Are there any questions at this point?
Jerry,
Yes,
Kathy Rosenberger, I have a question.
go ahead.
When she talked about the deep ocean buoys that they use for research, are they tethered to anything?
That's a great question. Actually, no. They are allowed to drift freely with the currents, almost like a balloon in a way in the wind, and which will blow along with the wind. So these are drifting free buoys that drift along with the currents, and we track where they are underwater using sound. There is, however, another method for measuring ocean currents, which we call the current meter. And that's a bit like an anemometer, if anyone knows what that is, which is a spinning device usually that measures wind speed. We use something similar in the ocean, and it is tethered at one place and measures the speed of the water going by that one place. So two different methods for measuring ocean currents.
Like a windsock.
A windsock tells you, it tells you two things, right? It tells you the wind direction, right? Because the windsock sort of spins around depending on the direction. And then depending on the windsock on how straight out it is the speed of the wind, right? So yeah, it is similar.
So
Go ahead.
Are the buoys that are down there, are they weighted?
Yes, they are. They are precisely weighted, in fact, so that they will sink to a specific depth where the current is that we want to study. Because in fact, ocean currents are not the same from top to bottom of the ocean. In fact, quite the opposite in some places. They can be in opposite directions at the surface of the ocean and down deep. So sometimes we're looking for a current at a particular depth. And so we weight them very carefully within a few grams. And they usually weigh about 15 kilograms, okay, the whole thing. So we have to get its weight known to within a few grams in order to place it just at the right depth.
Thank you.
And I believe Terry has his hand up. Terry, if you have a question, feel free to unmute yourself.
Thank you very much. This is a absolutely fascinating call to me. I grew up on Cape Cod, and it was always when we were little kids, to give you an idea how old I am. When we were little kids, every time we went to Falmouth, we would always want my mother to drive by Woods Hole so we could see Alvin.
Yes. Well, Alvin is still doing well. In fact, this is Alvin's 60th birthday this year.
Oh my God.
Yeah.
That's amazing. I thought that he was probably long gone.
Oh, no. It's been massively rebuilt. Like there's probably almost not a single piece that's exactly the same. It's been, updated, and now, in fact, can go much deeper than it used to be able to. So it's been upgraded significantly, but still has the same name, still has the same mission.
For heaven's sake. Let me ask you this. This is my question, actually, is the deep water currents.
Mm-hmm.
They roughly, I guess I'm wondering, do they cause some of the deep water pressure,
Mm-hmm.
like with those people that were killed in that
Mm-hmm.
two-man sub a few
Mm-hmm.
years ago that tried to go to the Titanic,
Mm-hmm.
or the one that I'm thinking more about is, do those currents affect something sitting at the Thresher, for instance,
Yeah, right. Mm-hmm.
sitting on the continental shelf? Would those currents ever be strong enough to knock it off?
Yeah. Uh-huh. I see. Well, first of all, about the pressure, just the simple weight of the water overhead of, say, the Thresher or any other submerged vehicle like Alvin, just the weight of the water above it is enormous. It doesn't matter whether it's moving or not. Water is very heavy. If you've ever dove down, even at a beach, and swum underwater or in a swimming pool, when you get down to the bottom of the pool or, more than a couple, a foot or so underwater, you start to feel it in your ears, right? And that's just the beginning. Believe me, at the depths that Alvin goes to, or that Titan sub was at, or the Thresher, the pressure just of the weight of the water is enormous. Again, whether there's any current or not. And that is one of our biggest challenges in studying the deep ocean. In fact, is we want to send down all kinds of instruments with electronics inside that we don't want to get wet. And we have to build very strong cases or containers to put the electronics inside so they don't get wet and can withstand those kinds of pressures. Now, as far as the currents, probably not. If there is something sunken on the bottom, the currents aren't going to be strong enough to push it unless it's quite light. And but something, especially if it has filled with water and then the metal and like any shipwreck, right, is pretty much going to stick right where it landed. And then the sediments wash around it and can fill it up as well. And it's pretty rock solid there. Trying to think if there's any counter examples I can think of. But certainly the currents do push around sediments on the bottom, even the deep ocean. Also, the currents move around nutrients that are very essential for life in the ocean, big time.
Well, thank you very much for all of that. I just find it fascinating. I
Yeah,
would have loved
me
to
too.
have gone into oceanography about a long time ago
Uh-huh.
when I was headed into college.
Uh-huh.
As a
It's
matter
a
of fact,
bit.
my sister tried and she ended up in medical. Uh,
Yes, yes.
Thanks again. It's been
Sure. My
this is
pleasure.
a fascinating call.
Oh, I'm glad you enjoyed it.
Anyone else have any questions? Well, hearing none, if you want to play that last clip of yours, Doctor, that'd be
Okay.
great.
Okay. Okay, this one, let's see. I'll ask y'all if you have some preferences. Is everyone still unmuted, Jerry? Or maybe we could
Yes,
raise hands.
they are. Yep, they are.
Okay. I have two options. We could learn about underwater volcanoes or shrimp-like creatures that swim up and down in the ocean in order to avoid being eaten and avoid daylight. So underwater volcanoes or life in the sea. Any preference?
I vote for volcanoes.
All right.
Yeah, volcanoes.
I like volcanoes too.
All right. Here we go then. This one has some great sound effects too.
Balance restore. Do you know what this sound is? It's a recording of an underwater volcano. Let's explore with our ears.
That was actually the rock making noise.
Whoa.
Mount Vesuvius in Pompeii, Mount St. Helens in Oregon, Kilauea in the Hawaiian Islands, and Eyjafjallajökull in Iceland. These are all volcanoes, some of which you may be familiar with or even may have visited. While we often think of volcanic eruptions on land coming from the tops of tall mountains, Most of the Earth's volcanic activity happens on the bottom of the ocean. One very active underwater volcano is the Axial Seamount volcano located in the Pacific Ocean about 300 miles off the coast of Washington state. This volcano has been studied by scientists for decades, allowing us to not only learn about what happens when it erupts, but also begin to predict when those eruptions might occur. Like volcanoes on land, magma, also known as lava, slowly fills up a chamber below the underwater Axial Seamount volcano. As magma builds up, this chamber inflates like an expanding balloon, pushing up the seafloor. When an eruption occurs, magma explodes from the volcano into the ocean. The magma chamber quickly deflates, causing the seafloor to drop suddenly. Scientists can measure this rise and fall of the seafloor by measuring ocean bottom pressure, or the weight of the water pressing on the seafloor. When the seafloor drops, there is more water pressing down, and when it rises, there is less. The following data sonification explores bottom pressure data from 1997 through 2021. The data tracks the long-term changes in the seafloor of the Axial Seamount volcano as its magma chamber inflates and deflates. You will hear the rise of the seafloor over a long period of time as the magma chamber fills under the ocean floor, followed by a sudden drop in the seafloor as magma is released into the ocean during an eruption. For our data sound exploration, an eruption event will sound like this. Magma filling its chamber and inflating the seafloor will sound like this. Let's listen to one eruption cycle from the Axial Seamount volcano. The following data sonification will play bottom pressure recorder data from 1997 through 2011. You will hear eruption sounds indicating the 1998 and 2011 volcanic eruptions and year markers every 5 years.
1997. 2000. 2005.
Wow! You can almost feel the seafloor suddenly dropping as the volcano explodes magma into the ocean. It happens much faster than the magma chamber filling, which can take years. Now, let's listen to the full bottom pressure data set from 1997 to 2021. The data sonification includes eruption sounds marking the 1998, 2011, and 2015 volcanic eruptions. Year markers are not included. By watching this pattern of eruptions over many years, scientists can begin to make predictions of when an eruption will occur. For the Axial Seamount volcano, it appears that when the seafloor inflates by about 3.2 meters, or 10.5 feet, a volcanic eruption may soon occur. Scientists call this number an inflation threshold. Let's listen for how this inflation threshold lines up for eruption events during the data sonification. For the following data sonifications, the inflation threshold will sound like this. The next data sonification plays bottom pressure data from 1997 through 2021, but adds a marker to indicate when the inflation threshold is reached. The track includes eruption sounds marking the 1998, 2011, and 2015 volcanic eruptions.
1997. 2022.
Did you notice how the 1998 and 2011 eruptions occurred just as the seafloor rose to the inflation threshold? The 2015 eruption, however, occurred after the inflation threshold was reached. The axial seamount volcano has already reached inflation threshold again as of 2021. Scientists predict that an eruption could occur at any time. Let's listen one more time and see if you can guess when the next eruption will occur.
1997. 2022.
Okay, I'd be happy to answer any more questions or any comments. Just to clarify on that last one, we heard the very, very beginning, there was that low rumbling sound. That actually was real sound that happens during an earthquake, an underwater earthquake. But everything else after that was synthetically made with a computer that was translating the numbers into sounds. And the numbers are just a string of numbers that measure the pressure of the water on the seafloor over time. So it's just one long string of numbers, and we put that to sound to show how much the seafloor was rising and then collapsing, and then rising and then collapsing during each eruption.
I got a question.
Please.
If I was on a cruise ship and I was out in the ocean just having a really good time, there's a volcano underneath us, would we feel anything?
Not likely. Not likely. I won't say never. It would depend on several factors. How deep is the ocean underneath the ship? And, how deep is the volcano? If it's very, very close to the bottom, it's, a couple of miles at least below you. It will depend on the strength of the eruption. But there could be eventually, like say within, it's a bit of a guess, within about a half an hour, you may see bubbles come up to the surface of the ocean because there's a lot of gases that are expelled as well as the lava during an underwater eruption. So, but it's not like the water would explode. Yeah.
Thanks. It's very interesting.
I think so too.
I just got new Bose speakers. I had to turn them down.
Oh, I know. It's a bit loud. Yeah. I know. You got an earthquake going on in your house or a volcano.
Exactly.
Well, I want to thank Dr. Bauer for coming out today. That was really interesting presentation, and we certainly appreciate you coming out today.
Yes, I really appreciate your time as well. And if you want to learn more about that project, you can go to a website, Accessible Oceans, which is all one word, that I can't say, accessibleoceans.hui, that's WHOI, for Woods Hole Oceanographic Institution, .edu. So accessibleoceans.hui.edu. And you can listen to more of the prototypes there. There's also, if you go to the blog, there's actually a link on the blog to a survey that we would love to get your feedback on our prototypes. It's a 15-minute survey, and we're trying to improve them and figure out how effective they really are at teaching ocean concepts. So thank you again.
Thank you. And thanks everyone for coming out today. Have a fantastic weekend.
In Maryland's tech-savvy land of innovation, a group of minds with wisdom and elation. The technology user group, a shining light, brings knowledge to the people day and night. With meetings and events, they share their might. In forums and workshops, they ignite the passion for progress. They never tire and bring the future closer like a burning fire. Their expertise in tech, a treasure to behold, a wealth of knowledge young and old. From coding to AI, they dive and soar and make the complex simple once more. With every step, they pave the way for a brighter tomorrow today. In Maryland's tech scene, they shine so bright. The technology user group, a beacon of light. In Maryland's tech-savvy land of innovation, a group of minds with wisdom and elation. The technology user group, a shining light, bring knowledge to the people day and night. With meetings and events, they share the might. In forums and workshops, they ignite the passion for progress. They never tire and bring the future closer like a burning fire. Their expertise in tech, a treasure to behold, wealth of knowledge young and old. From coding to AI, they dive and soar and make the complex simple once more. With every step, they pave the way for a brighter tomorrow today. In Maryland's tech scene, they shine so bright. The technology user group, a beacon of light.
This has been a presentation of the Maryland State Library Agency. For links to additional resources provided by today's presenter, please visit the show notes. For more information on MSLA or the Maryland State Library for the Blind and Print Disabled, visit marylandlibraries.org.